Hello students, in our last class we have discussed about refraction of light, how it is different from reflection of light, what is the reason behind refraction of light, and also I have asked a question that when a ray of light falls at an angle at the surface, it undergoes refraction, but when an angle falls perpendicularly, it does not undergo refraction. So let me tell you that light is made up of number of particles. So these particles are the main reason behind refraction of light in different mediums. See, when a ray of light falls perpendicularly, what happens that all of these particles, so I have just highlighted some of the particles here, all of these particles hit the surface at the same time, and so their speed changes also at the same time. So what happens? It goes straight away without any change in direction or without undergoing refraction. You can imagine this, that say we are traveling by a car, and suddenly what happens? We apply the front brakes and both the tires are stopped at the same time. What will happen? The car will skid, or it will just move on straight without going in any sideways. Okay, so but let us consider this one, a ray of light falling at an angle to the surface. What happens? You can see here that this particle, which is at the lower end, hits the surface at a faster rate as compared to these particles which are on the upper side of the ray of light. So what will happen? This ray of light will hit the surface fast, and it will decrease its speed fast or earlier as compared to these particles. So as a result, what happens? There is a unsynchronized way as how the speed of these particles are decreased, and that is the reason why it changes its direction. When we say that when light passes from rarer to denser medium, it bends towards the normal, and from denser to rarer it bends away from the normal, that is because of precisely this reason. Now let me explain it to you in this with another example. Let's say again we are traveling by a car, and suddenly the left side of the car or the left tire of the car gets jammed. What will happen? The car will suddenly move at a slower rate, and it will change its direction in the left side. But on the same in the same car, if the right side tire is jammed instead of the left, the car will automatically move it to the right side. So the same thing happens in case of light also. These particles, say in this figure, let us consider this figure. In this figure, when this ray of light is traveling from a rarer medium to a denser medium, I have already explained it to you, the definition of optically rarer and optically denser in our previous video or previous class. So here we can see that a ray of light is moving from air to glass, or from optically rarer medium to denser medium, and so these particles are hitting the surface at an earlier rate or at an earlier time as compared to the other particles. So its speed decreases earlier, and so it moves in this direction or towards the normal. Okay. Similarly, when it is moving out of the denser medium to a rarer medium, what happens? These particles hit the surface earlier, and since it is moving to a rarer medium, its speed will increase, and that's why this one will move in such a way that it will move away from the normal. So that is the reason why a ray of light traveling from rarer to denser medium bends towards the normal, and a ray of light moving from denser to rarer moves away from the normal. It is because when an angled ray hits the surface, its different particles hit the surface at different times, and the speed changes in a different way. But when a ray of light hits it perpendicularly, all the particles are hitting the surface at the same time, and so there is no change of direction, or a perpendicular ray does not undergo refraction of light. So when it is entering from rarer to denser, these particles on the lower end are decreasing their speed at an earlier rate, and so it is bending towards the normal. When it is moving out from a denser to rarer medium, these particles at the lower medium are experiencing an increase of speed at an earlier rate as compared to the other particles. That is why it is moving away from the normal. Now, today in our video, we are going to discuss mainly these things: the refractive index, speed of light, reason of change of direction, and lateral displacement. I have already told you the reason of change of direction. What is the reason? That different particles are hitting the surface at different times, and they are experiencing a change in speed at a different rate. That is why refraction of light takes place, or a change of direction takes place. Moving from rarer to denser, it moves towards the normal, and from denser to rarer, it moves away from the normal. Regarding lateral displacement, let us consider a ray of light coming from air to glass and then again moving out to air. What will happen? When it is initially coming from air or rarer medium to glass, that is denser medium, it will bend towards the normal. And again, when this ray of light is going out from the glass to the air, what will happen? It will bend away from the normal. So, this is the distance which is from its original path. And this distance, or this moving away from the original path after multiple refraction of light, is known as lateral displacement. We have already studied lateral inversion in reflection of light. Don't confuse with that one, but it is a different phenomena here. It is the displacement of a refracted ray of light from its original path after experiencing multiple refraction of light. So these 2 points are covered, and the main point today is refractive index and its relation with speed of light in that medium, or in the mediums concerned. So last time I have, while discussing the laws of refraction, I said that sin I by sin R equal to constant, and that constant is known as refractive index. So that is in the mathematical formula, and now let me explain it to you. What is refractive index? Refractive index is the strength, or is the angle, or is the ratio by which a surface is going to bend the ray of light. That is, how much the ray of light is going to bend from its original path, or will be the change of direction, that is defined by the refractive index. And while saying refractive index, it is always of the medium in which the light is entering. For example, here in the first case, the refractive index of glass with respect to air. That means we are talking about the capacity of glass, how much it is going to bend the ray which is coming from air. And in the second case, when we say refractive index of air with respect to glass, it means how much the ray is going to change, or how much refraction it is going to experience when coming from glass and entering the medium air. So it is denoted by a symbol like this, where we write it 1 by 2. This means refractive index of the second medium with respect to 1. And if we write it like this means refractive index of 1 with respect to air. Now, with respect to 2. Now, let me tell you, if we are saying that the light is entering from air to glass, it will be the refractive index of glass with respect to air. Again, if we say that light is entering into air from glass, it will be refractive index of air with respect to glass. And as you can see that if these mediums are related to each other, the relation between them will be inversely proportional. That is like this. Why it is so? Because the angle at which glass is bending the ray, the same angle will be experienced in a different manner, in an opposite manner when it is entering air from glass. So, if you are saying that refractive index of, say, let me tell you the, let me assume that if the refractive index of glass is 1.5 with respect to air, the refractive index of air with respect to glass will be 1 by 1.5. Let me rephrase it again. If the refractive index of glass with respect to air is 1.5, this means the bending capacity of glass is 1.5, not of that of air. If we are talking about the refractive index of glass, and since it is coming from air, so we will say it refractive index of glass with respect to air. So, if we change it like refractive index of air with respect to glass, in our second case, it will be 1 by 1.5. That is inversely proportional of each other. Now, there are some common terms in this chapter like refractive index of glass. That means if the ray is coming from air to glass, means if we don't mention with respect to anything, then it means it is coming from air. Refractive index of water, that means light is traveling from air to water or from vacuum to water. If we mention refractive index of glass with respect to water, then we are talking about the bending capacity of glass when ray is coming from water. If we say that refractive index of water with respect to air, that means we are talking about the bending capacity of water when ray of light will be coming from air and entering water. So, this is what refractive index is, and it is directly related to speed of light. So, last time also in our class we have discussed that it is the speed of light in different medium which is mainly responsible for refraction of light. As different mediums have different densities, their bending power or their speed of light in them will be different. That is why refraction takes place. Now, using this relation between speed of light and refractive index, we can solve a number of numerical problems. For example, refractive index of 2 with respect to 1 will be speed of light in medium 1 divided by speed of light in medium 2. Now, out of these three unknown factors, if we know two factors, then we can easily calculate one factor. For example, let me say that we know that refractive index of water with respect to air is 1.5. So, what we can say? Refractive index of water with respect to air is speed of light in air divided by speed of light in water. Now, if we know the refractive index of water with respect to air, or if we know, simply saying, if we know the refractive index of water, we can easily calculate the speed of light in water. How? Say, let us say that refractive index of water is 1.5. So, it will be 1.5 and the speed of light is 3 into 10 to the power 8. So, we can easily calculate this one by cross multiplication. Again, if it is given, let's say in a different way, that the refractive index of air with respect to water is 1.5. Okay, so we know that refractive index of water with respect to air will be inversely proportional to this refractive index of air with respect to water, and it is said that it is 1.5. So here we can put it like this. And calculate the speed of light in water. So this relation we will be using to solve our numerical problems. So this is how refractive index and speed of light in different mediums are related to each other. So for today this will be all, and if you have any confusion or questions you can leave it in the comment section, and if you like our video then you can please like, share and subscribe to our channel. Thank you.